Okay, so we're looking today at essentially a historical timeline of before we knew what atoms and elements were, all the way up to today's current view of what we know of as being the atom. So before we knew what atoms were, and actually before there were teachers and schools and scientists, we had something known as philosophers. Okay, so what a philosopher was essentially, usually it was an elderly person in a community that basically, at the time, how you gained knowledge was through life and living. So I pretty much want to say most communities or different cultures, usually the elderly people are known as the wiser people, right? So the people who have lived and experienced life the longest, usually those are the people who pass down their information and their knowledge to the younger generations. So in Greek and Latin times, or even in the Roman age, philosophers were essentially that. So, philosopher was usually an older gentleman, and they were people who were seen as the wiser of the people in the community, who were there to basically guide younger generations with knowledge. Okay, so typically, if people had questions, they would go to a philosopher or an older person to seek answers. Okay, so Aristotle is one of the more famous philosophers. If you continue on and you take philosophy in grade 12, you'll learn probably way more about Aristotle than you will right now. But for now, before there were elements like we know elements on the periodic table, there were elements that they believed made up all four basic particles of life. So, not elements on the periodic table, but they believed that there were four elements of the universe. So, all things were made up of air, water, earth, or fire. So, or some combination thereof. So, for example, someone might say, "Hey, Aristotle, what's that thing in the sky?" Like the sun. So they didn't know that the sun was basically a ball of hydrogen gas that was causing nuclear fusion and energy to be released. They probably said, well, you know what? It's a big ball of fire in the sky because it's hot and it's releasing energy, right? So they didn't know, of course, they didn't know about the elements like we know about the elements today. Okay, so this was essentially what was believed for a very, very long time. So the first idea of the atom, when it came about in 400 BC, so a long time ago, essentially the first idea, the thought was it was essentially a solid sphere. So think of like a billiard ball or like a pool ball. Like it's a dense, hard, like essentially sphere of matter. So who did this was essentially another philosopher by the name of Democritus, and it was from Greek origins. And so this was more than 2,400 years ago, keep in mind, okay? So what he kind of, and this is not a real picture, of course they didn't have photography then. This is actually a statue, a picture of a statue that was made to sort of mimic him. But anyways, I digress. So Democritus essentially thought of, okay, well, let's take a chunk of something. Okay, so let's say we have a big rock. And if you were to cut that rock into half, like you chisel it, you have a big chisel, and it's now split in half. Right? So imagine you have a rock and we split it in half. And then we take that half and split it in half again. And then we take that half and split it in half again, etc., etc., etc. Like half and a half and a half and a half. And you keep going and you keep going. Democritus pretty much hypothesized that there had to be a limit to this. Like there had to eventually be a point where the particle of rock is so small that we couldn't split it any further. Okay, and he hypothesized that that small part that you could no longer divide out anymore was essentially what an atom was. So he asked himself, could matter be divided into smaller and smaller pieces forever, or was there a limit? So essentially what he theorized is that, yeah, matter can't continue to be divided indefinitely. There had to eventually be a small piece. And that piece he believed was indivisible, so like the smallest possible particle. And he named that small piece atmos, which the Greek translation means not to be cut or indivisible. So, and it didn't matter what it was. So let's say this was a chunk of rock. Let's say you took a piece of cheese and you cut it in half and you cut it in half and cut it in half. Eventually you would get to a small sphere of cheese. So keep in mind, he didn't know about elements and of iron and silver and gold and all that yet. But he believed that whatever matter you looked at, there had to be a limit to that matter, to whatever that happens to be. So unfortunately, I did mention that he was a that's not his name. I did mention that he was a philosopher as well. And actually, he lived around the same time as Aristotle. So the unfortunate part of the story here is that a lot of people thought that he was essentially going crazy. Nobody believed Democritus's idea about this atom. Like, well, what do you mean? We have elements. We have earth, air, fire, and water. These are what makes up the world. There's no such thing as these atmos that you're talking about. So yeah, basically they thought he was kind of nuts, and people ignored his theory, which is unfortunate. So people still believed Aristotle's original idea about the original kind of 4 elements, and I use that term very loosely. So what ended up happening? So of course, obviously, they didn't live for 2,000 years. Philosophers can't come and go, and life goes on. And people still believed Aristotle's idea for a very, very long time, okay, until the 1800s. So almost 2,000 years went by after their deaths, after Democritus' death, and finally he was proven to be correct, that there were these things called atoms. So at the end of the day, he was correct, but it took a long time for that to be proven. So John Dalton was a scientist that started to essentially prove the idea about atoms. So he performed many different experiments, too many to probably name. His whole life's work was revolved around trying to get the acceptance of this idea about atoms. And eventually he did. He was vindicated, and it was true. So this is just a summary of the main ideas for Dalton's theory. So number 1, we know that matter is composed of indivisible particles known as atoms. Now, at the time, there was nothing known about what is inside of the atom. So right now, they believe that this is the smallest type of particle. They don't know about anything that is in the atom yet. Okay, so it's kind of like a solid sphere, like the original idea. All atoms of a particular element are identical, which we know that that is true. So if you have, helium, all atoms of helium are the same. If you have atoms of silver, all atoms of silver are the same. And of course, we know that different elements have different atoms. So if you have helium and silver, they're going to be different because they're made up of different particles. So what did Dalton's model look like? Essentially, it was a featureless sphere. So basically a solid, dense piece of matter. Okay, they don't really know anything else beyond that. But of course, we're going to see that later on, some scientists did evolve that idea. Okay, the next scientist to come along was Thompson, J.J. Thompson. So Thompson's main discovery was the electron. Okay, so the electron was a small particle that's inside of an atom that has a negative charge. Okay, so electrons, sometimes the symbols we use for electrons is a lowercase e with a negative symbol, just to represent that it is negatively charged. So I'm going to put some links on our D2L to videos that will go into a little bit more in depth of this experiment. But essentially, what you need to know is that like charges repel. Okay, so negative and negative things repel or push away from one another. So essentially, in a nutshell, what Thompson's experiment proved is that negative charges pushed away atoms. So meaning that there had to be something negative inside of the atom in order for it to repel against something that is negative. Okay, so he proved that there was an electron. So now what does this mean? So because we have these electrons that are inside of atoms, this means that there is something inside of that dense sphere. So instead of being a featureless ball, we now have negatives inside of it. We have negative charges. So the atom was now being proven to have something on the inside. So we could divide it out further. Now, to continue, so he never proved this next part, but he had an idea that he hypothesized that if there was something negative in the atom, he believed that there had to be something positive to balance out those negative charges. Okay, so actually what his idea translated into is this model of the atom where you have little negative electrons, but he believed that the positive ball or the sphere was on the outside. So instead of, so here's Dalton where you had nothing except a sphere. He now believed that there were, well, for sure he proved there are electrons without a doubt. We know there are negative charges. But he hypothesized that the sphere was a positive charge so that the positives and negatives balanced out with one another, which will later prove that this idea is correct. Maybe the structure of this is incorrect, but the idea of positives and negatives will eventually be proven. But for now, Thompson essentially proved that there were electrons, which means there's something inside of the sphere, and he hypothesized that there was a positive charge on the sphere part. So this model had a name. So the first one, it was just, usually it's called a billiard ball model, but Dalton's featureless sphere. So Thompson's is sometimes referred to as plum pudding or raisin bun or chocolate chip cookie model because it kind of looks like a chocolate chip cookie. So imagine like the dough is positive and the little negative electrons are almost like chocolate chips in the cookie. I mean, these are just analogies, but you know, it's an easy way to remember it, I guess. All right, so I'm going to leave Rutherford for the rest of this for the next part of the video.